Welcome to Brain Vision.
Okay, so in this question, we have a tuning fork that is placed at the open end of a tube filled with water. And so the water starts at a distance of 20 centimeters from the open end of the tube. So we'll call this D initial. And the water is slowly lowered through a valve at the bottom, so that the distance of the amount of the tube that's filled with air increases with time. And we are told that the frequency of the tuning fork, F, is equal to 512 hertz. And like I said, the initial distance between the open end of the tube and the water is 20.0 centimeters, or 0.200 meters. And our job in this problem is to figure out what the next two modes or resonances are of this tube that is, filled with water, and the water is decreasing. So what that means is we're supposed to figure out the two resonances, the next two resonances that happen in the tube that have a distance greater or a length greater than 20 centimeters. So the way that we can do this, I'm going to redraw the problem. I'm going to draw it horizontally because it helps. It helps with visualizing it a bit better and making it more like other problems in this part of the book. So I'm going to redraw it like this. Basically, we have an antinode at the open end at the left, and then we have a closed end that can move to different distances. So we have a closed end, at a certain distance that will create a resonance, and then it'll have a certain greater distance that'll create another resonance. And so at the open end, we're going to have an antinode because it's right next to the tuning fork, so it'll have the greatest change in intensity. But when the standing wave reaches the water, it's going to have a node because it's changing media. So the standing wave will always have a node when it reaches the water. So in order to create a resonance, the wave has to have an antinode at this tuning fork and a node at the water. So the shape of our wave is going to be something like this, and so on. And then this would be our third distance. So if we look at this, we can see, and then we've seen this pattern in other problems as well, we can see that the first possible distance for creating a resonance would be the distance is equal to lambda over 4, because we've just gone from an antinode to the adjacent node. And then the second distance would be 3 lambda over 4, because now we've gone down to the opposite antinode and then back to a node, but we haven't quite returned to the initial antinode. And then the third possible distance for creating a resonance would be at the distance is equal to 5 lambda over 4. So the distances that we care about are equal to lambda over 4, 3 lambda over 4, 5 lambda over 4, and so on. So what we want to do is we are given that that the frequency of the tuning fork is 512 hertz. We can assume that the speed of sound is 343 meters per second, because we haven't been told that the air temperature is anything other than the room temperature, and we haven't been told any information otherwise. So we can assume that the speed of sound is 343 meters per second, which means that we can calculate the wavelength of this sound wave. And from there, we can figure out which of these distances that would create resonances, which are the first two that are greater than 20 centimeters. So that's exactly what we're going to do. So first of all, we need to calculate the wavelength of this wave. So the wavelength is going to be equal to v divided by f. That, of course, comes from the wave equation v equals lambda f, and just rearranged with some algebra. So we can go ahead and plug in 343 divided by 512. And that gives us that lambda, the wavelength, is equal to 0.670 meters. And then we just try these different distances, the lambda over 4, 3 lambda over 4, 5 lambda over 4, and just we try those until going from the smallest one to the largest and to bigger ones. We try those until we get the first two that are greater than 20 centimeters. So the first possible distance is lambda over 4, which is equal to 0.670 divided by 4. And if you calculate that, you will get that distance would be 0.167 meters. Now that's obviously less than 20 centimeters, 0.2 meters, so that is not one of our answers. So the next one, 3 lambda over 4, is equal to 3 times 0.670 divided by 4. If you calculate that, you will get 0.502 meters. Now this is greater than 20 centimeters. So this is our first answer, and then we know that the next answer will be our second one. So, and then 5 lambda over 4 is equal to 5 times 0.670, divide that by 4, and you calculate that, and you will get this distance of 0.837 meters. And obviously that is also greater than 20 centimeters, so that's our second answer. So our answers for this question are 0.502 meters and 0.837 meters. And that is how you solve this problem.